This call is now being recorded.
Okay. Okay. Assalamualaikum and very good morning to everybody. So today we are going to continue with our lesson under the topic of elasticity. Good morning, Archana. Okay. So during our previous class, we have discussed about the spring constant. Yeah. Good morning, Abi. Okay, the spring constant and also about the elastic potential energy obtained. Good morning, Vaij. Okay, obtained by a spring when it is compressed or when it is extend. Okay, so that was the previous class. Today we are going to continue with the same subtopic. We are going to talk about the spring constant and also about the elastic potential energy more deeply. Okay, and we are going to look at problems involving spring. And also we are going to discuss what is the factors that affect the spring constant and the stiffness of a spring. Okay. Okay, but before that, let's look at a simulation on if we did the experiment for elastic, it would be the arrangement would be like this. Okay, we are going to hang our spring on a retort stand, and we are going to place a ruler very near to our spring. Okay, and we are going to put a pin to show the position of extension of the spring. Okay, so let's say if we hang 50-gram mass or load onto the spring. Okay, we are going to move the, hold on, but before that, we must place the ruler so it is easier for us to read the data. Okay. So if you look closely at the simulation, before we hang any mass or any weight, the ruler or the spring or the pointer at the spring is showing 40 centimeter. Okay, so that is the initial position of the ruler. Okay, and then when we hang 50 gram of weight, it extends up to, if we look closely, it is 48 cm. Okay, so let's say if we increase, we hang 50, the initial position is 40, and then the final position is 48 cm. Okay, so let's say we increase the weight up to 60 gram. Okay, so we can see that the extension of the spring increases. Now it is 50. Okay, so this is how we do the experiment, and this is what will happen to the spring. As we increase the mass, the extension of the spring will increase. Okay. Okay, so let's continue with Hooke's law. Hooke's law ni ada tanya dah kan previous class, what is Hooke's law? So Hooke's law is a law that states that extension of spring is directly proportional to the force applied on the spring provided elastic limit of the spring is not exceeded. So this is Hooke's law. So if you are to define Hooke's law, this is the definition of Hooke's law. Okay, if we hang more mass or more weight, like in the diagram, okay, at first there is no weight hang on the spring, but then as we increase the weight, okay, the extension of the spring is increasing. And there is one condition, the force exerted does not exceed the elastic limit. Okay, so that is Hooke's law. And from the experiment or from the activity of hanging weight onto a spring and relate the extension to the weight, we will get a relationship between the force and also the extension of the spring. So from here, if we draw a graph relating between the force and the extension, we will get the relationship is directly proportional, referring to the graph, and the graph will give us a constant gradient. Okay, so in this case, the gradient is called spring constant, which is, we give the symbol K. Okay, so this is where the equation of Hooke's law came from. F equals to Kx, where F is the y-axis, K is the gradient, and X is the x-axis of the graph. Okay, so this is the origin of Hooke's law formula. From the experiment, we analyze the data and we draw the graph from the data that we get. Okay, from there we came into a conclusion that the relationship is directly proportional. Since it is directly proportional, this is the formula, the linear equation formula. And if we substitute the value, we get F equals to Kx. Okay, where F is the force, K is the spring constant, and X is the extension of the spring. Okay, so let's focus on the graph of F against X to determine a value of spring constant K, and also the elastic potential energy EP. We already calculated this during our previous class. So what can we say about kenapa lah saya punya line hari ni tak bagus? Asyik putus je. Sekejap ya. Okay, so a definition of elastic potential energy. So it is defined as energy possessed by elastic material. Okay, so the energy is possessed by elastic material when it is stretched or extend, or when it is compressed. So if the spring is not compressed or extend, so it will not possess any elastic potential energy. Okay, so definition for our question in SPM, you are to give definition of laws of physical quantity. So you need to know the definition. Okay, sebab kalau awak tengok, I'm not very sure about the first for the format for the 2021 format, but according to the 2020 the SPM format, okay, almost every question they will ask us about definition. Okay, sometimes dia tak sebut pun state definition or define. Dia sebut what is. So if the question asks us what is, it is expecting us for it is expected for us to define that physical quantity ke ataupun law. Okay, so spring constant is defined as force required to extend 1 unit of extension of spring. Okay, for the spring constant, we get the value from the graph, or we can also state or define the spring constant using formula. Okay, F equals to Kx. So spring constant constant K equals to force over extension. Okay, if we are going to use formula as our definition, we need to write the complete word for that particular physical quantity. Okay, so we get it from F equals to Kx. Jadi F is force, so kena tulis force. X is extension, so kena tulis extension. Okay, so spring constant is equal to, or spring constant is force divided by extension. Or we can write it in sentence. Okay, force required to extend 1 unit of extension of spring. Okay, actually this definition come from the formula. Okay, number 3, define the elastic limit of a spring. So elastic limit is defined as maximum force that can be applied so that the spring will return to its original length if the force is removed. Okay, as you can see in the graph here, there is one point. After the point, if the force is increasing, it won't follow the directly proportional punya graph anymore. Dia akan jadi high wire. Okay, because after this, extension dia dah tak directly proportional lagi. Okay, so this is elastic limit. If you have a spring, okay, if you pull the spring, it will return to original length. Tapi if you pull it too hard, dia dah loher-loher dah tak boleh balik pada panjang asal. Okay. So by referring to graph F against X and equation F equals to Kx, write an equation for elastic potential energy. Okay. So let's say we have a graph F against X, and X is in cm and F is Newton. So this is the graph of a spring. Sorry, dia lari sikit. Okay. If we refer to Form 3 punya topic, you learn about energy kan? And you learn about work. Okay. So to calculate work is force time displacement. Okay. Or energy in general is force time displacement. So if you look at the graph, F is the force and X is the displacement, because at first the graph, the spring is like this. When it is extend, dia displace lah. Okay, so W is Fx. So how to get Fx? F times X, which is area under the, okay, somehow the graph is directly proportional, so you won't get a rectangle or a square graph. So you, if you want to calculate the area, the formula would be half Fx. Okay, so let's say if we don't want to use the F, we want to use K and X. Okay, so from the Hooke's law formula, F equals to Kx. So what should we do? We can replace K with F over X. Okay. Oh, terbalik. Alah. Sorry. Okay, so we can replace F with Kx. Just now. So E is, Hmm. Okay. So we can replace F equals to Kx. So bila kita masukkan Kx in the when we substitute Fx this formula into this formula, you will get this formula, half Kx square. Okay, so where K is the spring constant, X is the extension, and F here is the force exerted onto the spring. So there are two methods to calculate energy stored or elastic potential energy of a spring. One is by using half Fx, and if we don't know the force, we can use half Kx square. Okay, so these two are the formula to calculate energy stored inside a spring. Okay, so
Teacher,
yes,
what is the SI unit for the elastic potential energy?
Joule.
Then why the just now the graph is F over X per cm? So for the elastic potential energy, do we need to divide by 100?
Uh, no need. Okay, because okay, so let's say for the A, we are using the graph kan, and then the graph is half Fx. So F is Newton, and X is cm. So the unit will be Newton cm. But if X is in meter, so the unit will be N meter or Joule. Okay, so when do we use Joule? And when do we cannot use Joule? We cannot use Joule if the unit for the axis or for the value that we calculate is not SI unit. Okay, for example, this graph. Okay, look at the graph. The force is in Newton. The extension is in cm. So when we calculate the energy using Fx, half Fx, so we get Newton cm. So we cannot replace Newton cm with Joule. However, if the unit here is meter, okay, if the unit is meter, Newton meter, then we can replace it with Joule. Okay, if it's an objective question, and if the answer all is in Joule, and the graph here shows cm, so you need to convert. You need to convert Newton cm to Newton meter. Okay, because sometimes for objective questions, the unit in the question is not SI unit. However, for the answer, the choice of answer is in SI unit. So bila dalam SI unit, so your calculations should be all in SI unit. Okay, SI unit meaning that Joule, Pascal, itu adalah SI unit. Joule, Pascal, lagi apa? Kilometer, meter per second, that all are SI unit. So if your question, the unit in the question is not SI unit, but the choice of answer is in SI unit, you need to convert everything to SI unit. Baru boleh dapat jawapan dia. Okay, boleh?
Then if in structure questions they didn't ask for the SI unit, so we no need to change
Yes.
the unit.
Yeah.
Oh, okay.
Okay, if the question does not state anything about wanting the answer is in SI unit, so you can give whatever unit you want. If you want to convert, then you convert. If you don't want to convert, also can. Okay. So I forgot to mention that for the energy potential and elastic potential energy in a spring, the SI unit is Joule or Newton meter. Okay, so that is the SI unit. Whereas for spring constant, the SI unit is Newton per meter. Okay. Okay, any questions so far under uh, spring constant and elastic potential energy? Tak ada? Okay, tak ada. So let's look at this. We have two spring 1 and spring 2. Okay, and the result of force and extension is shown in a graph. Okay, so the question is, calculate the spring constant for spring 1 and also the spring constant for spring 2 and calculate the spring constant lah dulu. So berapa spring constant for spring 1 and spring 2? Okay, you can write your answer in the chat area or you can switch on your mic. Okay, 100. 100 is for which spring? Spring 1 or spring 2? Okay, spring 1, the spring constant is 100 Newton per meter. Whereas for spring 2, the spring constant is
50.
50. Okay, so for spring 1, the spring constant is 100 Newton per meter, whereas for spring 2, the spring constant is 50 Newton per meter. Yes, okay, so this one is for spring 1 and this one is for spring 2. Okay, so from the spring constant, we can define the spring itself as 100 Newton of force needed to extend the spring by 1 meter. Okay, the meaning of 100 Newton per meter is 100 Newton of force needed to extend the spring by 1 meter. Okay, whereas for K2, for the spring constant 2, 50 Newton of force needed to extend the spring by 1 meter. Okay, so based on this, which one do you think is more stiff? Is spring 1 stiffer or spring 2? Which
Spring 1.
spring is stiffer? Yes, spring 1. Okay, spring 1 is stiffer. Why do you say that spring 1 is stiffer? Kasih, kenapa awak cakap? Why do you say that spring 1 is stiffer? More force needed to extend the spring. Okay, if the spring need more force to extend or more force to compress, that spring we say as a stiff spring. Okay, so this is a stiffer spring. Then the K2 is, or spring 2 is the soft spring. Okay, so let's look at this question. Okay, diagram below show the graph F against X for spring A and spring B. Both springs are made from same material, have the same original length, but different diameter. Okay, the spring have different diameter. A student extends each spring with different force and measures the extension produced. So, can you please calculate the spring constant for spring A and also for spring B? What is the spring constant for spring A and what is the spring constant for spring B? The spring constant for spring A with the unit. What is the spring constant for spring A? Where when?
Is this 0.02?
0.02. How do you get 0.02?
30 by 15 cm. Then after that, I will get 2. Then after the 2, I will divide by 100.
Okay. when convert the cm into meter. So the spring constant for spring A is the gradient of the spring. So you divide 30 with 0.15 meter. So 200 Newton per meter. Okay, if you don't want to convert to meter also can. So the unit will be Newton per cm. Okay, so what about spring B? Samitra. Okay, spring B. Yes, Samitra. What is the spring constant? Oh, lagging. Okay, never mind. Can Abirami? Abirami Sivaraja. Ada dua Abirami kan. What is the spring constant for spring B? Okay, 0.1 Newton per meter. So when we want to calculate the gradient, choose the value that we can use lah. Okay, so here the value yang senang nak baca is 10 cm and 1 Newton. Okay, so it's 100. 10 divided by 0.1 dia. Okay, so if it's cm, it will be 1 Newton per cm. Never mind. Okay, so this is the definition, the spring constant. Okay, 200 force needed to extend the spring by 1 meter, whereas for the B spring, 100 Newton force is needed to extend the spring by 1 meter. Okay, so now look at the next question. Calculate the elastic potential energy when X is 10 cm. I think it is for both, for spring A and spring B. What is the elastic potential energy? Ashley? What is the elastic potential energy for spring A and spring B? Yes, Ashley? What is your answer? Okay, maybe Ashley faced a problem with her internet. My internet is also not very good this day. I don't know why. Kasih Alia. What is the elastic potential energy for spring A and spring B when the X is 10 cm? Okay, if anybody want to try and answer, you can write the answer in chat area. Okay, 100 joule, 10,000, 100,000 joule, 100. Oh, banyak jawapan, macam-macam. Okay. Spring A, 100. Okay, as I've told you before, if you want to use the unit joule, you have to convert cm to meter. Okay, so it's actually 1 joule. The calculation here is using kx square, but if you use half fx also, you'll get the same answer. Okay, so for spring A, this one is for spring A, area under the graph for spring A. Okay, so is half 20 times 10 cm, but if you want to write the answer in joule, 10 cm will be 0.1. Okay, so 10 times 0.1, you get 1 joule. Ini jauh sampai must be in meter or cm. You can use both. You can either use cm or meter. However, depends on your last answer. If your last answer you use the unit joule, it cannot be in cm. Okay, so that is a condition if you want to use unit joule in your final answer. Okay, so if you don't want to use joule, your calculation should come up with Newton meter. Newton cm. Okay, so if it's in joule, you have to convert cm to meter. Okay, I repeat, if you want to use joule, the unit should be Newton meter. But if your unit is Newton cm, you cannot use joule. Boleh? Okay, so let's look at spring B. For 10 cm, what is the energy? Spring B, 0.5 joule. Okay, very good. Okay, boleh? Yes, 0.5 joule. So this is how we calculate our elastic potential energy. We can either use half kx squared since we already calculated the k, or if we have a graph, we can use the graph, area under the graph. Okay, because area under the graph is half fx. And please be reminded, if you want your unit to be joule, everything must be in SI unit, meaning that the force must be in Newton and the extension must be in meter. If you did not convert to if you did not convert cm to meter, then your final answer you cannot use joule. Okay, boleh? Okay, boleh?
Can.
Okay.
Yes.
If each spring is extended by force of 10 Newton, what is the extension of the spring? Okay, now the question is, saya padam, tak nampak banyak sangat. Okay, if the spring is extended by force 10 Newton, what is the extension of the spring? Okay, spring A, what is the extension? Which one? 5 cm is for which one? Ashana. Okay, spring A, the extension is 5 cm. We extrapolate directly from the graph. Okay, and for spring B, also we do the same, 10 Newton, extrapolate to the graph. Okay, we get 10 cm. This one is using calculation also can. Sebab F equals to Kx kan. So if we did not have the graph, then we use calculation. But if we have the graph, it's easier to use the graph. Okay. Mana-mana method boleh. If you don't want to use the graph, also can. You can use fx. But if the question state refer to the graph, kalau soalan kata referring to the graph, what is the extension of the spring if the force is 10 Newton? Don't use calculation. You must extrapolate from the graph. Faham? Okay. We answer according to what is needed by the question. Jangan ikut kehendak kita. Okay. The question say refer to graph. So you have to refer to graph. You have to extrapolate from the graph. Okay. If the question didn't say anything about graph, then you can use calculation. Okay. Is spring B suitable to extend with small energy? Ke ni soalan ke pernyataan? So spring B is suitable to extend with small energy. Okay. So we have looked at the spring constant and also the uh, elastic potential energy. So we are going to discuss factors that affect the spring constant, okay, and the stiffness of a spring. So if you have two springs, one spring is shorter than the other. So the shorter spring have high spring constant compared to the long string. Okay. And when the spring constant is higher, therefore the spring is okay. Whereas longer spring has lower spring constant and the elastic the spring is softer. Okay. So this is one factor, the initial length of the spring. Okay, that is why initial length of spring we can use as constant variable. Okay, let's say we have spring, satu spring kita nak cari Hooke's law kan. Okay, so the question asks us what is the constant variable? One of the constant variable we can use is the initial length of the spring. Mesti ada perkataan initial. If you say that the constant variable is length of spring, salah. Because if you hang weight, the length of spring will increase because the spring is extended. Or if you compress the spring, the length of spring will become smaller. Okay, so for constant variable, if we want to look at the relationship between force and extension, one constant variable is initial length of spring. Okay, so let's look at the next factor, diameter of spring. Okay, diameter of spring is, let's say you have a spring, is the diameter spring tersebut. Diameter untuk dia punya lilitan. Okay, the coil of the spring. What is the diameter of the coil of the spring? Okay, if the diameter of the spring is smaller, then the spring constant is higher. Therefore, that spring will be stiffer. Okay, so when we talk about the initial length, when we talk about the diameter of spring, you have to bear in mind what is changed here is only the factor that we talk about. Let's say we are discussing about diameter of spring. So only the diameter of spring is different. Okay, the initial length is the same. The thickness of the spring is the same. Okay, so when we talk about one factor, the other factor that affect the spring constant must be the same or must be constant. Okay, so thickness of the spring. Well, actually, this one, we should do the experiment to prove this. Okay, so when we go back to school, okay, there will be, I think, 3 experiments that you are going to do on the spring itself, or 2 experiments, sorry. One experiment is to prove Hooke's law, the relationship between weight and extension. And the second experiment is to relate the factors that affect the spring constant. Okay, so kita akan fokus 2 factors sahaja. Tak boleh nak fokus banyak-banyak, nanti banyak sangat report nak kena buat. Okay, so there are 4 factors that affecting, actually there are 5 factors that affecting the spring constant of a spring. However, type of spring material, if you if the question asks us about constant variable, please don't use type of spring material. Okay, because for experiment, katalah soalan dalam bentuk eksperimen kan, the question asks us what is the constant variable. Okay, avoid using type because we cannot measure type. For variables, only the physical quantity that can be measured used. Okay, for variables. Yang tak boleh measure, kita tak guna dalam variable kita. Okay, this is for physics. Kalau untuk yang lain, bio and chemistry berbeza. But for physics, untuk when you do experiment, all the variables must be measurable. Okay, even though type of spring material is one of the factor. Okay. Ni kita sekejap. Okay. Saya kata ada 5. We have looked at the diameter of the spring, thickness of the spring, initial length of the spring, and type of the spring material. This is another factor that affect the extension of the spring, which is the arrangement of a spring. Spring can be arranged in series. Series maksudnya one spring after another. Okay, and also spring can be arranged in parallel, one spring next to the other. Okay, so if the arrangement of spring is in series, it's like this, whereas for parallel, it's like this. Okay, so what do you think will be the extension of the spring? Or how is the spring holding the load? So let's say the load is M. Okay, and then this one is also M. How will each spring hold M? Okay, so if the arrangement is in series, the first spring will hold M, the second spring will also hold M. Maksudnya the weight dia akan pegang is M, and then the next spring is also M. But if it's arranged in parallel, the load is divided among the spring. So this will hold half of the M. This one will hold half of the M. Okay. The stretch force applied on the spring act on each spring. Okay, maksudnya every spring will get, kalau you arrange 3 series spring, so one spring will have M, this one will hold M, this one will hold M. But if it is arranged in parallel, kalau 3, divide lah. Dia akan jadi 1/3 M, 1/3 M, 1/3 M. Okay. So for the spring, since one spring is holding M, so the tension will be one value lah. Whereas for the parallel one is half. It is half because dia 2. If there are 4 parallel spring, dia akan jadi 1/4. It will be divided equally among the spring. Okay, if it in series, all the spring will hold the same force. Okay. As for the extension, if you have 2 series spring extension, each spring will extend X. So ini akan extend sebanyak X. This one akan extend sebanyak X. So the total extension for in series is 2X. Okay. Whereas for the parallel arrangement, dia hanya akan extend half. Logic lah, because each spring is holding half M. So the extension is half compared to the series one. Okay, so this one dia tak tambah because it is parallel. Therefore, this one the extension is still half X. Okay, in series the extension is plus ataupun kita add because it's one after another. So one extension become very long. So dah jadi 2X. But this one both extend 2X, half X. So dia punya extension only half X. Okay. And then as for the spring constant, the spring constant for series arrangement will become half, whereas for the spring constant for parallel will become double. Okay, spring constant relate to stiffness kan? So stiffer spring extend very small when force is exerted. So bila in series dia jadi extend double. Therefore the spring constant become half. But for parallel the extension jadi half. Therefore the spring constant become double. Okay, sebab dia opposite. Stiffer spring will have smaller spring constant. Okay. Total extension of spring is if used in springs. Okay, so this is the total extension. Okay. So far, any question on the factor involving spring constant?
Yes, teacher. Where do you get the spring constant from?
The spring constant we can get either from calculation. Usually, the question will give us the F and the X. Okay, you calculate the K. Okay, let's look at example of question. Macam ni tak nampak kan? So, let's look at example of question. Okay, so let's look at this one. The original length of spring is 5 cm. With a load of mass 20 gram, the length of spring is extended to 7 cm. Okay, A, determine the extension of the spring with a load of 40 gram. Okay, when we get question related to spring, the question will usually give us the initial length and then the extension of spring when some load is put onto the string. Dia akan bagi the first reading biasanya. Okay, so dia tanya extension of the spring with a load of 40 gram. So macam mana cara? Actually, there are two methods to calculate. Ada dua method. One is by using direct. Yang if a combination of series and parallel arrangement, how do we measure the tension? Okay, never mind. We are going to look at the question. Okay, 14 cm. Okay, so let's look at the extension of the spring. Either it is 14 cm or is it different measurement? Okay. So the answer is 4 cm. Okay, ni dia guna apa? Ni apa? Perkadaran dalam bahasa Melayu lah, but I don't know what is in English called. Dia when X is like, okay, this one, this is the initial length, this is the extension, so the extension X is 2 cm. Okay, when 20 gram. Ini macam what we call in bahasa Melayu is perkadaran. 2 cm you get 20. So X or 40 you get Y. Macam tu. Okay, so this is what I said that I said before as one of the method. Okay, and the other method is we calculate the K first. So using F equals to Kx. So when the F is, you don't have to convert to Newton. Okay, when the F is 20, X is, you need to calculate the extension first because this is the initial. This is after we hung the mass. Okay, so X is 2. So K equals to 10. Okay, so now we use K 10. We substitute into this formula. Okay, F now is 40. With the K value, we already calculated as 10. So X is 4. Okay, so there are two methods. Proportion. Ratio, it's not ratio. Okay, so this proportion method you can use. Which one you think is easier? Up to you. Okay, but if it's for me, I would prefer if you answer in Hooke's law formula. Okay, because ada certain question awak guna proportion dia tak berapa accurate. Okay, so I would prefer if you use F equals to kx. And if you use F equals to kx, you don't have to convert the 20 gram into Newton, the 2 cm into meter. You don't have to. Okay, because your answer will be in cm also. Okay, because you're using the same mass. Okay, so the answer is 4 cm. And then for B, the length of spring with load of 60 gram. Berapa? Cepat kira. 21 cm. Ada 11 cm. Ada lagi tak? 11 cm. Tukar pula 11 cm. Okay. Oh, sorry. So using the same method, the proportion method, okay, 20 gram will give you 2 cm. So 60 gram will give you what? Okay, will give us 6 cm. But this is the extension. But the question wants us the length of spring. Okay, the length of spring. So the length of spring, you must add the original length of spring. Yang ni extension. So there are two different questions. A asks us to calculate the extension only. So the extension only is 4 cm. You don't have to add the original length. But for question B, the question asks us the length of spring. So you have to add the initial ni dia tak campur ni, 6 cm plus 5 cm, 11 cm. Okay, so there is a difference between question A and question B. Okay, nampaknya ramai anda boleh dapat jawab. Yang ini. Ya, apa? Ambil yang ni lah. Yang tu saya tak faham apa dia nak. Okay. So let's look at this example. The original length of spring is 10 cm. When it is stretched by a force of 6 Newton, it extends to 13 cm. So the first question is, what is the spring constant? And B, two identical springs. So it's identical to A. Okay, are connected in series. What is the total length of the spring if stretched by 12 Newton? And C, the same spring is connected in parallel. So the total length of spring system. Okay, so berapa? K is 2. Ada lagi, Abirami, K is 2. Kasih, K is 2. Tajwini, K is 2. Okay, everybody is giving me K is 2. Okay, so K is 2 Newton per cm. Okay, so B. With the same spring, the spring that have 2K, what is the total length of the spring if it's stretched by 12 Newton force? So how do we calculate? What should we calculate first? Oh, but before that, what should we know according to the arrangement of the spring. Bukan what should we know lah. Yalah, apa yang perlu kita tahu tentang susunan spring ni is in series. So how is the division of force on the spring? So berapa? Okay, 2 times. Okay, so the extension will be double. So each spring will get 12. This one will also get 12 Newton. So if the spring extend 3 cm for 6 Newton, so what would be the extension of the spring if there are 12 Newton? Sebab kat sini kita dah dapat kan 6 Newton, extension is 3. So if 12 Newton, extension would be 6. Okay. So each spring will extend 6 cm. Okay, so this is calculation yang tak ikut langkah-langkah step by step. Sekejap Okay, I'm sorry for the interruption. Okay, so we know each spring will extend 6 cm. The question wants us to give the total length. So what is the total length? From the first spring to the second spring. Berapa? 12? Total length, bukan total extension.
32.
Okay, if total length, 32 ke? 12, yes. If total length, the initial length of the spring, this one is 10. You plus the extension, and then the initial length of spring for this one is also 10, plus the extension. So the total length is 32 cm. Okay, so if the question asks us what is the extension, then 12 cm is correct. But the question asks us the total length. So you have to add in the original length. Boleh? Okay. So let's look at C. Two identical springs are connected in parallel. So what is total length now? But before we can calculate the total length, we must know how the force is being divided by the spring. Okay, for B, all spring will get the same force, which is 12 Newton. But for C, what would be 6 Newton for each spring? Yes, okay. So this one will get 6 Newton. The next one will also get 6 Newton. Let me erase this one. So from A, we know that when the force is 6 Newton, the extension is 3 cm. So this one will extend 3 cm. This one will also extend 3 cm, 3 cm. Yes. So the total length of the spring now is 13 cm. Very good. Okay, yang ni tak payah add dia punya extension because they extend sama-sama, the 3 cm. Since the question wants us to give the total length, so we add the initial length. So the total extension is, or the total length is 13 cm. Okay. So let's look at the ni kejap BM, kejap BI. Ini calculation ataupun jalan kerja dia. Okay. So any question? Okay, kalau tak ada apa-apa question, we are going to discuss this next week. Saya akan bagi exercise ni for you to answer first. Okay, and for those who haven't submit your exercise 2, please do so. Ada lagi yang belum hantar, ramai lagi yang belum hantar. Okay, I mark your exercise as PBD. Nanti kan PBD awak tak cukup markah. Okay, sebab form 3 nak masuk form 4, kita ambil PBD untuk tengok dia punya package. So I don't know for SPM what they are going to use the PBD for. Yang belum mark nanti saya akan mark. Okay, sebab beraya. Okay, so with that, we stop here. Nanti saya akan bagi this exercise untuk awak try and answer. Okay, thank you, class. Okay, thank you. Yes, thank you.